Hello, everyone. Thank you for joining today's webinar. A couple of things before we get started. This webinar is being recorded and will be emailed to you in the next couple days. If you have any questions, please type them into the Q&A window on your screen, and we will answer them at the end of the presentation. Today, we're going to talk about how to secure every device and protect your network. I'd like to introduce you to our speaker, Abhi Maras, Principal Products Manager at Ruckus Wireless. And with that, I'd like to hand it over to Abhi to get us started.
Thank you very much, Carly. Good morning, good afternoon, good evening, everyone, depending on wherever you are. Today, we're going to talk about how to secure every device on the network. Now, what do we mean by every device? We're talking about every end-user device, be it their IT-issued devices or their personal BYOD devices, or even IoT devices that are coming up on the network, either as bring your own IoT devices or even IT deployed BYOD or IoT devices. Now let's see the drivers as to why this has become a challenge. Now, of course, those who have been in the industry for the past 10-15 years would see the great shift or change that we're seeing, where the industry or any enterprise network for that matter had very few devices to begin with. Most of them were connected to the wire, and Wi-Fi was always seemed like a nice to have IT service, and frequent disconnect was often tolerated because it was a luxury item. Fast forward today, and that's not the case anymore. There are more devices on the network, and these wireless devices are mission critical, and we got to make it work always. And I recall one of my colleagues who said that Wi-Fi is like flowing water. You've got to have it. Now, coupled with Wi-Fi becoming the predominant way to connect, and in addition to that, becoming challenging to offer high quality of service, there has been a lot of strains that has been on the enterprise networks. The other big issue that we have seen is where there are fundamental shifts even in user behavior. There are, of course, large growth in devices and also users, but there is another challenge where there are multiple operating systems, and gone are the days when the network was all Windows domain-owned devices. Today we have MacBooks, we have Windows devices, we also have non-traditional devices like Chromecast and so on. And of course, add BYOD to that, and now we have plethora of operating systems that are playing our networks. Now, the other challenge is because there is high user adoption for several of these operating systems, giving a common platform to secure all these various operating systems has been a challenge so far. Norton recently did a study, and what they found was that about close to half of the adult population accessed their personal emails on unsecured connections. And a large majority of them, over 2/3 of them, used public Wi-Fi at some point in time or unsecured Wi-Fi in some shape or form. And the interesting thing is about half of them who used free or unsecured Wi-Fi were concerned about their security. And it's unfortunate that even though there was a concern of security, there was no solution because of the rampant availability of open or unsecured Wi-Fi all over the place, or in hotels, in hospitality establishments, in stadiums, and so forth. Now, why do we see that? Now, before we really go and try to solve that problem, there's a couple of things that I wanted to talk about. There's a lot of misconception when we talk about secure Wi-Fi. Secure Wi-Fi is not a captive portal. It's not a web login. Just because we go into a captive portal and put in a room number and last name, it's not an authentication, or it's not security. It's not even MAC authentication or proxies or gateways. Even a shared password more than 10 devices doesn't qualify to be a secure Wi-Fi. When we talk about secure Wi-Fi, we're talking about a WPA to enterprise connection. Now, there's also another misconception when we talk about Wi-Fi being secure or the network in general being secure. If you look at the OSI model today in security and translate that to security, It's kind of like an iceberg situation where, there is a lot of emphasis on security on, layer 3 to layer 7. Now, of course, it's important to secure layer 3 to layer 7. There's a lot of bad stuff that happens in layer 3 to layer 7. But there's an equally dangerous or more dangerous problem that happens in layer 2. And that's where the problems are often ignored. Now, when we talk about MDM or web logins, NACs, even web proxies and so forth, they often play in the layer 3 to layer 7 space of security. But the challenges that I'm referring to is in the layer 2, where things like, for example, evil twin attacks, sniffers, spoofers, man-in-the-middle attacks, theft of credentials all happen in that space. Of course, a lot of websites today are moving over to SSL encryption, but there are a few challenges with that. Not every site is SSL encrypted, and SSL encryption comes at an added cost of computing, and due to that, typically SSL is protected only for username authentication or initial few user sessions, and not all content in a page is SSL encrypted. And there's been a lot of reports on the users where even though they have SSL encryption, sometimes they can't get their credentials. But for example, in be it Facebook or any of the other social logins, once you're logged in, there are a lot of data that can be constructed post login, and information can be leaked. Now, there are other problems with unsecure, public Wi-Fi or guest access Wi-Fi's. The unsecure and public Wi-Fi hotspots are everywhere, and they're often a very tempting target for hackers. Be it Wi-Fi, guest Wi-Fi in a shopping mall, or in a movie theater, or even in hotels and so forth. There's a lot of risk from infection from malwares that can be planted from these unsecure connections. In addition to that, cell phones, once they're connected to a network, even though you're physically not using the phone and the phone's in your pocket or purse, the phone is always transmitting data. It's always looking for notifications. It's always trying to use the background connection for data exchange. And all that happens over unencrypted connections. In addition to that, hosting an unsecure open Wi-Fi has its own risks as a owner providing that service. And in addition to that, there is an added challenge where it's very easy to create a fake hotspot. Anybody could bring in an AP, a consumer grade AP, configure it to have the same SSID as the establishment, and let it sit in the vicinity where devices will automatically connect and transmit a lot of data to that particular network. So why are we doing all this if it's so risky? Well, one of the prime drivers is, open Wi-Fi is convenient. It's convenient for end users because they don't have to configure the device. And it's also convenient for administrators because it's easy to set up and it doesn't take a lot to bring an SSID up. But that definitely comes at a cost. And the cost is usually security. So how are we trying to solve that? Now, here at Ruckus Brocade, we have something called as a Ruckus Cloud Path Security and Policy Management Platform. Now, the way I look at it, there are multiple items or multiple components needed to solve this problem. And when we looked at this challenge, we said, okay, how can we solve this? And solving this didn't involve having one component. It involved a lot of components to solve that problem. It needed a radius, it needed some sort of an onboarding solution, it needed certificate authorities, and so on. So we took all these disparate platforms or products that are needed to create a secure network, and we plumbed all these together to offer what we call as a security and policy management platform, which can help secure your device, not just on a encryption level, but also from a policy standpoint, which I'm going to talk about in a little while here. Now, CloudPath, the way I look at it is kind of a Swiss Army knife of edge network. It does a lot of things, but if I had to categorize three broad areas in which it will help us secure our networks, the first and foremost is, of course, the policy management. Policy management, simply put, is making sure every device that comes onto the network gets attached to an appropriate policy. And when I say a policy could simply mean a VLAN, or it could be as complex as saying this particular device is a guest device, so I'm going to give it only internet access, versus this device is an IT issue device, so I'm going to give full access to the network. It could also mean bandwidth throttles, where a device could have only X megabits of data versus another device could have Y. And it can also be a combination of several of these parameters too. The second broad area is what we call device enablement and onboarding. Now, of course, simply put, it means enabling a device to get connected. But there's a lot more that happens here where, in addition to getting the device connected, we can do a lot of checks on the device to make sure the device is healthy enough to join the network. The third piece is, of course, security and certificate management. Why certificate management, you ask? Well, certificates are the gold standard in security, and while we do a lot of different forms of authentication on the network, we recommend or gravitate towards certificates, and I'll talk about each of this in a little bit more detail in the coming few slides. We also offer this solution as a hosted public cloud and also an on-premises VM solution. And of course, there are several forms of licensing available, both subscription and perpetual, which I'll talk a little while later. So let's look at each of these three components that I talked about. The first component that I talked about was policy management. Now, policy management, like I said, simply put, looking at each device that's coming onto the network and applying an appropriate policy. Now, there's two components to it. One is the policy itself, and the second most important component is how to make a decision of which device gets what policy. Now, the policy itself, like I said, could simply be a VLAN, it could be a ACL, it could be bandwidth throttles, it could be a combination of all of these. But the decision to decide which device gets what policy stems from several different criteria. It could be a student device in case of an education. It could be a staff device again. In an enterprise setting, it could be an IT-issued employee device versus a guest device. It could be a BYOD device that an employee or staff or student brings onto the network. How do we look at each of these devices, make a determination of who owns the device, what is the category of the device, and we could also look at items like, for example, device operating system or even Active Directory membership group information, and make decisions in permutation combinations on what device gets what policy. And it's this capability of looking at every device and determining what policy this device should have is what constitutes our construct of the policy management. Now, we didn't stop there. What we did was we extended this to even IoT devices, where now IoT devices are posing the exact same problem that BYOD devices posed as a challenge a few years back on the networks. These IoT devices are also compounded in their challenge because of the sheer volume and the lack of ownership. When I say sheer volume, there are a lot of these devices that are popping up, especially devices which are IP capable, be it wired or wireless. And also, there's a challenge in ownership because of these devices are so inexpensive. These devices are not just popping up within the enterprise, which are deployed by the IT, but they're also popping up because end users are bringing them, be it in the shape of media devices or even smart devices. Now, the next piece that I spoke about was device enablement. How do we do device enablement? Now, of course, as quite simply put, it's enabling the device to get connected, but there's a lot that can happen when we make a decision of getting a device enabled to join the network. The first and foremost is checking the health of the device, checking whether the device has the right posture to join the network, be it as simple as checking whether a firewall knob is enabled on the device, or checking if an antivirus is installed and if it's updated on the device. Even checking whether device OS updates are up to date or not. It could also mean checking if there are some applications installed on the device. And it's not just making checks, but it's also remediating them. So if none of these parameters are matching according to what the administrator wants, how can we go and remediate them? How can we enable the firewall if it's disabled, or install an antivirus update if it's not up to date, or even install an application if it's missing on the device? Those are some of the capabilities that we enable to make sure the device is in compliance to join the network. The other important aspect that we also try to solve is, in Chromebooks. Chromebooks are coming up everywhere because they're affordable. They do the job, and because everything is in the cloud today, a lot can be done with a browser and limited compute in the edge. Now, what we did was we worked very closely with Google to have a VA API-based solution where we make Chromebook onboarding extremely simple and secure on the network. We have a CloudPath extension, which can be easily configured to have a Chromebook onboard easily onto the network. The third aspect also that we do a little bit different or uniquely is, of course, all platforms have some sort of a self-service onboarding for their devices. We took it a step further where we said, that's great, but I would also like to offer this for a end user or an IT or a distributor which can provision these devices upstream. And in addition to that, what we also wanted to do was allow it to pre-board the device. What it really means is, think about it as a TSA pre-check with mobile boarding pass combined. Now, what it allows users to do is onboard their devices in the comfort of their own home and onboard the device even before walking into the network. Lastly, integration with the MDM vendors, where we can integrate with MDM vendors. Now, of course, there's a lot of light MDM is what we call, which can secure the device, but we can also integrate with a full-blown MDM provider as well to have a single touch point for securing the devices and also determining whether it's a IT device or a BYOD device, and securing them appropriately between these platforms. Now, I mentioned about certificates a little while ago. Now, while CloudPath does a lot of different forms of authentication, like PEEP, where it is username password based authentication, we do, of course, EAP-TLS. We do MAC authentication, web authentication. We even enable devices to do EAP-SIM authentication. But we recommend certificates for the most part, and a few of the reasons for that are certificates are unique on every device. It allows policies that can be applied on a per device basis, be it VLANs, ACLs, and a whole lot more. And certificates are also highly manageable because we get visibility into each device, and we can have control over policies and also revoke access on a per device basis without having to just disable the account entirely. Certificates are also gold standard in security. Everybody knows that certificates are the best way to secure, but the challenge always has been that they are extremely complex, and because of the complexity, a lot of administrators tend to shy away from certificates and use other forms of authentication which are a little less secure. Now, what we've tried to do is make PKI and TLS in general a lot more easier, not just for the end users, where we make it as easy as joining a PSK or a guest network. And also with the admins, we have set up of these secure networks as easy as possible, where it's as complex as setting up a PSK-based network, and that's what we're striving for, is to simplify this where the benefit of security can be accessed by many. And of course, certificates are also non-stop, because when a device connects and as long as the certificate is valid, the device continues to operate as long as the account is valid and the certificate is still active. So none of these constant password changes will affect the connectivity of the device. And in turn, it translates to a lot more fewer help desk tickets. Now, the other aspect was, of course, every network's requirements are unique. And there are networks where we need simple onboarding methods. There are networks where we need a complex system to be more granular and to be more specific. Within CloudPath, what we have is what we call as a workflow, which is an easily buildable workflow. Think about it as a flow chart, where when a user starts their journey or enrollment journey into the network, we walk them through a series of steps, which makes it extremely easy to get onto the network. And these workflows can be built with these modules that can be easily plugged in to offer something very simple, very fast, or something very sophisticated, which can translate to a highly granular policy-based access based on several parameters that we can check. Let's talk about a little bit on the deployment. CloudPath, of course, is, like I mentioned before, is available both as a public hosted cloud solution and also an on-premise solution in the shape of virtual machines or Hyper-V. And CloudPath can talk to various different identity providers as well. Of course, we have an inbuilt user database, but we can also very easily talk to external user databases like Active Directory, LDAP, Radius, even social login via OAuth, SAML, and so on. From an authentication standpoint, we also have an inbuilt Radius server. But if there is a deployment which already has an external Radius server, we can even connect or plug into the external Radius server with the same functionalities. CloudPath also has an inbuilt certificate authority, which makes deploying PKI extremely simple and easy. But for deployments which all have an existing CA, and if the admin chooses to use the existing CA, we can easily plug into an existing certificate authority like a Microsoft CA. CloudPath is also vendor agnostic, so it will work with any standards-based wireless LAN vendor. And it's not just wireless LAN, it's vendor agnostic even on the wired side, so it's infrastructure agnostic too. So be it a device joining wired access or wireless access, we can apply the same policy on the same device irrespective of the method it's joining onto the network. Any standards-based wired or wireless LAN networks is interoperable with CloudPath. Here are some of the components that are available within CloudPath. Of course, we have an internal Radius, which is extremely efficient and closely coupled with .1x and PKI. And we also have an inbuilt PKI solution where we can create root CAs, multiple sub CAs, we can chain, and so on. And it makes it extremely simple because everything is plumbed together, so there's no separate configurations needed to plug in Radius with PKI and with device provisioning and so on. From a provisioning standpoint, we support pretty much any operating system under the sun. So any operating system that the end user may have is easily can be easily provisioned with CloudPath. From a user database integration standpoint, we integrate with existing user databases like AD, LDAP, Radius, and so on. From a device management standpoint, we can enforce a lot of device-specific settings like antivirus, firewall, passcodes, NAC, proxies, and so on. We also offer guest access, and we offer both secure or even traditional self-service guest access. What I mean by traditional self-service guest access is guest access that we typically see in shopping malls and on hospitality, where you basically put in a accept the terms and conditions, and there could be some form of a username authentication of some sort or registration of some sort. In addition to that, we also secured the secure access to guests, where even guests can now get the benefit of a secure connectivity onto the network, because we have made it so simple where an IT admin doesn't have to get involved in offering a secure network even for guests. And of course, the policy engine, where we can enforce custom end user or device specific privileges. The other interesting capability that we have is also the integration via APIs to other network elements. Now, one of the interesting things we found was, we built a product which can do a lot of things, but we quickly found out that the more we can talk to other network segments, the sum of parts is larger than it is. And when I talk about other network elements, I'm talking about, of course, the wired and wireless networks. In addition to that, when we talk to firewall devices or MDM vendors or even IoT gateways, there's a lot of capabilities that arise where we can share user identity information, traffic patterns, and so on, which will enable us to not just detect, but also enforce or protect or take action on particular devices if there is any threat that is identified. Few of the examples that I would like to give are, of course, it's not limited to these few names, but I chose these few names to talk about to give a context of what I'm really talking about. Now, when we look at firewalls are great, and especially with the next-gen firewalls that are out there in the market, like Palo Alto, they can do traffic policing to a very granular level. But there's always been a problem or disadvantage for these firewalls, because they sit up high in the network where when data reaches these firewalls, they see one big fat pipe, and they don't usually know which user a particular traffic session belongs to. Although they can differentiate sessions, they don't know the ownership of those sessions. What CloudPath does is it sends user identity information to firewalls, where now firewall has the ability to look at a session and know accurately who that particular session belongs to, and because of that, a lot more detailed or granular policy can be enforced on the firewall. For those of you who are joining from Europe or even North America for that matter, Eduroam in higher education has been very popular, where it's a roaming network or roaming consortium between education networks. CloudPath is part of this, and CloudPath also is deployed in a lot of universities across the globe which are subscribed to Eduroam. So we're part of this Eduroam network, which makes it extremely easy for users to roam across disparate networks. Chromebooks, like I mentioned a while ago, we have very tight, streamlined Chromebook authentication, where we get the search directly on the TPM chipset and make it extremely simple and easy to onboard via Chromebook onto the network via the Chrome extensions. From an MDM integration standpoint, we can, when a device comes onto the network, we can make an accurate check whether the device is something that's an IT issued device or if it's a BYOD device, and we can make appropriate policy decisions based on that. And in addition to that, even MDM vendors can leverage the certificate authority and CloudPath for all the devices. Lastly, content filters. Now, content filters are a very interesting topic because of CIPA compliance and a lot of other compliance requirements, networks were kind of enforced to have a content filter, and all that was great because content filters did a really good job in looking or inspecting the traffic and trying to see if there's anything malicious in the network. But while content filters itself were great, the challenge was all the sites now are moving over to SSL encryption. Because of the SSL encryption now, what's happening is these content filters are unable to look at what's happening inside the session, so they're not able to inspect the traffic in the network. What this integration with content filters allow is the ability to enforce user certificates on the client devices and also enforcing proxies on these client devices so the traffic will be directed towards the content filter. And at the same time, we also can issue a root certificate to content filters, where now content filters can decrypt the session and inspect the traffic and move it on in the network. Now, of course, it's not needed on all the destinations, but on certain destinations, like for example Google, where of course we can't block Google on a network, but Google can sometimes be a blessing. Sometimes it probably is not so much. So this enables us to inspect specific destinations, look at what searches is being done on the network, and take appropriate actions based on that. A lot of times it's also a compliance requirement, but we're helping these content filters become a lot more relevant again. Talking about client support, we support a broad host of clients. Of course, Chromebooks are a very tight integration to us. We support the big four, obviously, which is the Android, iOS, Windows, Mac. We also support Linux flavors, both Ubuntu and Fedora, and we also support BlackBerry. And it's not just the breadth of operating system, it's the depth as well, because we support pretty much more than 2 or 3 years of version on a lot of these platforms. For example, Windows we support all the way from XP, so it's pretty much a catch-all situation. And the support is not just limited to the icons that you see on the screen right now. These icons are there because of a integration where we can actually look into the operating system and do certain actions, like for example enable pin locks, or even check for firewalls and enforce application installs and so on. If you don't see a particular OS here, it means that we can still configure them to join the network, but we can't do specific checks on the operating systems and automatically get them connected. That's basically what it means. From a self-service onboarding standpoint, most of these onboarding functionalities are day one activity, which means a user comes on the network, they go through a process to get their devices configured, and that's it. As long as they are allowed to be on the network, they don't have to do anything else. So they still connect automatically with the appropriate policies without them having to do anything. And even the day one process is extremely simple and straightforward. It can be as simple as an admin mons or as complex as it's required. But here's an example that you will see on the screen now, where we have taken an example of an education environment where a user comes in, logs in, gets appropriate policies, and configures their device. Now this is again a standard page. It's fairly straightforward, and in this case what's happening is after they accept terms and conditions, they're basically logging on via Active Directory. In this case it's an Active Directory. They log in, and once they log in, basically they're presented with this package, depending on, of course, what membership they belong to within AD. And what's really happening when this gets installed is it's doing these NAC style checks, whether it's trying to check for firewall, it's trying to check whether the device is compliant, and it's also pulling a certificate and getting it installed on the device. And it's also configuring the device to join a secure network. And it may not be only one, it could be multiple networks within the same installation. And it moves over the device to the secure network in the process. And in addition to that, it also can forget a unsecured network if it's configured. So if you're next to a Starbucks and if your devices end up in Starbucks SSID, you can actually disable that from the device joining that SSID too. So all this takes about 10 seconds or so, and that's pretty much it. And that's just a one-time effort where day two experience, the device just connects automatically to the secure connection and it just works. It's fully authenticated and fully encrypted session from there on. So because we've tried to make certificates so easy, this is something that can easily be extended even for guests on the network, and that's the biggest benefit that we have when we are trying to expand the horizon for secure access even for guests or BYD devices. Now, there are several ways in which we can get a device configured. Of course, one of the examples you saw in the previous screen was an Active Directory-based authentication. But for employees, if it's if it's an IT asset, we can check for AD. We can even issue a voucher and so on, and make it a lot more complicated. For visitors, if it's a sponsored visitor, we can ask a sponsor to approve or deny access, and not just approve or deny. A sponsor can also decide how long does this user have to be on the network. It could be minutes, or it could be days, or it could even be years. In addition to that, we also do unsponsored access. So if there's a visitor who doesn't have a sponsor, we can simply ask them for an email or an SMS and have a two-factor authentication where we'll send in a code and they put in the code and get onto the network. These are just examples. There's a whole host of workflow components available which can fine-tune the kind of access that we want for end users to have. So it's highly flexible and capable in that sense. Integration to wired is also another interesting thing we do. Of course, all the parameters that I mentioned, be it from an authentication to even remediation of non-compliant devices, can be done on wired. In addition to that, we also support change of authorization, where we can, via radius change of authorization, we can send in parameters like ACL, disconnecting the client, flipping a port, re-authenticating a device, and so on. So devices that are connected either via wired or wireless don't have to go through re-authentication process. A new policy can be dynamically pushed to those devices without forcing re-authentication. Also, of course, there's a lot we can do on IT issue device and BYD devices. What about IoT devices? Of course, IoT devices have a lot of problems, or I wouldn't say problems, but a lot of challenges where IoT device doesn't have an interface. So interacting with an IoT device itself is a challenge. The other challenge also is how do we know what device it is before applying a policy, because no two IoT devices are the same. There could be an IoT device which is highly sensitive and transporting a lot of secure information, and it's important for the well-being of the network. On the other hand, there could be IoT devices that are fairly non-trivial. Could be like a vending machine or other devices which are not transporting any critical information, so they need to be treated differently. What we can help there is for IoT devices, first and foremost, we can fingerprint every device on the network, which means the platform knows when a device is trying to authenticate, whether it's a Nest thermostat, or whether it's a video IP camera, or if it's a vending machine, or if it's a personal BYOD iOS device. Based on the fingerprint information, we can automatically apply. We can automatically apply a policy on the network. The fingerprint information allows us to accurately know what exactly the device is capable of, and in addition to, of course, applying the policy on a particular device, we can also check the capability of the device. So, for example, if it's a Apple TV, we know what the device is capable of, versus if it's a thermostat or if it's a microwave, we know what the capabilities are, and we can onboard them appropriately. If devices are capable of doing certificates, we can issue certificates for them, versus if they are not capable of doing certificates, we can simply issue a pre-shared key. Or if it's in a ruckus wireless network, we can also issue a dynamic pre-shared key, where there is a unique pre-shared key for every device. For devices that cannot even do a PSK, we'll simply do a MAC-based authentication and get them onto the network. But of course, we can apply a policy appropriate where that particular device has limited access on the network, and also limited destinations that it can reach to. It's not just within the network, but it is also outbound we can control. So for example, if it's a Nest thermostat, it needs to only talk to certain destinations. It need not talk to Google, or it need not talk to Yahoo or any other sites. It just needs to talk to certain destinations that it needs to update information to. So based on which device is connecting, an appropriate policy which could translate to limited network access and even bandwidth throttle can be applied on the device. In addition to that, via APIs and other methods, CloudPath can also talk to IoT gateways, so we can update these gateways with appropriate information on a particular device or set of devices or even category of devices to exchange authentication or any other device information as applicable. The other interesting things that are also happening is if you look at networks today, every user is bringing different types of device. So obviously there is a laptop, but in addition to that, there's devices like mobile phones. In addition to that, we're also seeing IoT devices like be it smartwatches or other lights that are coming up on the network. And the demands of the interconnection between a user's devices and also the broadcast and multicast nature of the traffic between these devices, there's a lot of demand to have personal networks where each user can have a personal network for him or her, where devices can talk to each other, share broadcast multicast information without interfering with another user. Now, what we're trying to do there is to offer what is called as a personal network where every user with a unique key or with a unique VLAN or such can isolate themselves. Now, the beauty about all this is also that irrespective of the device capability, where certain devices are capable of doing a very comprehensive certificate-based connections like mobile phones or even laptops, versus devices like which could do only PSK, irrespective of the method of getting connected, we can still offer a personal network irrespective of the device capability. So that's another powerful way of isolating devices on a per user basis. And even devices that are unable to do certificates, we can still deliver individualized key via SMS or email to those devices, which can be used for the WPA2 encryption on the network. So we're extending these capabilities not just for traditional devices, but even for headless devices as well. And in addition to that, this can be also be overlaid with this concept of a role where we can attach a specific device permissions on a per user basis. So if a gold user is on the network, all the devices that belong to the gold user, irrespective of the method of access, get the same policies on all their devices. Versus if it's if the user with the role silver gets a different level of access on the same network without joining a different SSID. So it's all on the same SSID, but with different VLANs and different access permissions for that particular user's devices on the network. And of course, we have this concept called as workflows, where, like I mentioned before, it can be easily something very simple can be quickly created, or we can add a very complex or comprehensive workflow pattern. And that enables us to very quickly and easily build a sophisticated workflow which has a very granular policy-based access on the network. There's also a whole host of customization available. Of course, what you're seeing on the screen is somewhat of a standard screen. All I've done is upload a background information. I also have uploaded a logo, but all these are just point and click kind of changes. If a user needs to get more fancy and have a more customized page, we also allow users to upload a custom HTML page, which can do a lot more than background images and so forth. From a licensing standpoint, one of the key things to note is that CloudPath is offered as a user-based license. What it really means is we look at a network as a number of users. We don't look at network as devices. Now, a couple of the reasons why we do that. First thing is when administrators look at the network, they know how many people are walking into the door, but they don't know how many devices each one brings. So it's very hard to make an estimation of how many licenses they really need. In addition to that, a lot of times vendors say use into 3 or into 5, where every user brings in 3 or 5 devices. But what often ends up happening is there is undersubscription or oversubscription. With that in mind, we said, you know what, we're going to do a concept of a user-based license, where if a user brings in 10 devices, 20 devices, it doesn't matter. It's still counted as a single device, or single license rather. And we have both a subscription-based license and also a perpetual licensing option. Of course, perpetual licensing option is offered on an on-prem solution. A cloud-hosted solution is offered only as a subscription model, and it's extremely simple, where we just need to choose the number of users and choose the duration of subscription, and that's it. So it's extremely simple. There's no module-based licenses. There's no additional components that need to be purchased. There's one single SKU, and we've tried to keep things extremely simple from that sense. And a lot of customers tell us that we're about 3 to 4 times more affordable than a lot of our competitors. In addition to that, we do what is called as a white glove service, where we actually come in and help deploy to the customer. Think about it as very, very light professional services, where we can remotely get the customer up and running in a matter of few hours. And the customers still have the option of calling the hotline and getting their if there's any changes they need, they can always come in, and we'll help them out. And of course, we have a separate list price for education as well. So that's basically what I had for today, and I wanted to keep some time aside for Q&As as well.
Great, thanks, Abhi. And we do have some questions, and if anyone else has any other questions, feel free to enter them into the Q&A section, and I'll read them out loud. So the first question, can CloudPath work with Ruckus Wi-Fi partners' Wi-Fi monetization engagement, such as Ragapa, Purple, and Cloud for Wi-Fi, or Cloud for WE?
Yeah, that's a very good question. Yes, CloudPath can work with existing Ruckus Wi-Fi partners. We do have quite a bit of deployments where we are working with some or all of these vendors. So we work very tightly with these vendors, either via standards-based connections like Radius and so on, or via APIs, where we can enable them to connect to us, either for securing end-user devices or even improving network visibility.
Great. And then a related question, will CloudPath work in a mixed environment, meaning we have 2 different types of APs?
Yeah, that's another good question. So yes, CloudPath can work in a mixed environment. So if you have a network where, let's say, for example, if your indoor Wi-Fi is all Cisco and outdoor Wi-Fi is all Ruckus, that's another classic use case where CloudPath can help bridge these two networks together. So if end users join via a Ruckus network, they can seamlessly roam to a Cisco network, and the same authentication backend can be used.
Great, thanks. The next question, we currently have 4 SSIDs broadcasted. Can CloudPath just use one SSID and then the certificate known for Active Directory? What group to put the user in for access?
Yeah, so a lot of our customers have this requirement where, they acquired companies, or they were acquired and there were multiple Active Directories now, or multiple groups within Active Directories. So what we can actually help there is CloudPath can talk to multiple ADs at the same time, or even within a nested situation scenario, we can look at which AD the user belongs to and take an appropriate action on what policy to apply for the device. So we can talk to either nested ADs or disparate ADs as well, where these kind of scenarios exist. And that's another classic example where in these kind of situations, we want users to be able to roam from one space to the other, even though the back office merging has not happened. That's another aspect where even though the SSID names are different or the wired networks are different, by pointing everything back to the same CloudPath instance, either by a proxy or using the same system, we can also make sure there is seamless roaming across these networks.
Great. Next question. Does CloudPath support game consoles and devices such as Chromecast as well as various smart TVs?
Yes, it does. And one of the ways it does is, let's say I as a user, of course, I would have an Active Directory account and I can easily get my smart devices on the network. But the challenge with these headless devices is that these headless devices can do only PSK-based authentication. So what users can do in those situations is we offer workflows where a user can log in and register their Chromecast or other device and get a key. And that key can be used to put into the Chromecast or Fire Stick or any of these devices. And when they join in, they get the same policy as I would have on my smart devices. Even when a device cannot do a pre-shared key, or even, for example, if it's not a Ruckus wireless network where there are dynamic keys are not available, a user can still register the MAC address and make sure that when the device tries to connect to the network, it gets appropriate policies because the MAC of that particular device is tied to that particular user.
Can Google authentication be limited to only their Google Suite domain and a user's Gmail account?
Yes. Yes, we can definitely do that. So there's an option called as filters, where we can filter the domains that the user can bring in. And because we use OAuth to authenticate a lot of these accounts, via OAuth we can also filter domains and such based on what we get back from these authentication sessions.
Do Wi-Fi certificates? Oh, go ahead.
Sorry, go ahead.
Do Wi-Fi certificates need to be purchased one per device?
No. So the certificates are can be done either on a user basis or a device basis. But from a licensing standpoint, we don't treat each certificate as a license. We treat each user as a license. So irrespective of number of devices, it'll still, or rather certificates, it'll still be a single license for that particular user.
Great. So So what does the SSID look like for these headless devices? Is it an open network? Please describe the authentication process for them.
Great. So let's take an example here. Let's take an example of an MDU or a dorm room where there are multiple types of devices. Now, let's say I'm an end user and I have a laptop and a smartphone. So typically what happens is there is an open network which could be used for guest access or just plain onboarding. So I'll join this open network and I get redirected to the portal and I go through my onboarding process. And eventually I get a certificate which is installed and my device automatically connects to the secure network. Now, let's say, for example, I have an Amazon Fire Stick or an Apple TV or a Chromecast that I want to bring onto the network. What I do is, because these devices don't have browsers and they cannot even do MAC-based authentication via the browser like we would on a guest network. So what we typically do is an end user can use their laptop or smartphone and go into this portal, and once they log into the portal, they will get an option to add a device, and they just simply click on that button and they can register their device. For example, request for a key, and when they request for a key can be emailed or SMS'd to them. And when it's emailed or SMS to them, they can put in that key on the Chromecast interface or Apple TV interface. And when they join in, they get appropriate policies because the server already knows that this particular device is registered because it either identifies the MAC or it identifies the key that it issued for that particular user. So there could be 3 SSIDs, an open SSID for all the onboarding and guests. There could be a PSK or a dynamic PSK SSID for all these headless devices. And there could be an EPTLS SSID for certificate-based authentication for smart devices. I hope that
answers. Great. Yeah. The next question, when are we expecting CloudPass 5.1 GA?
So CloudPass 5.1 is, so for those of you who are not aware, so 5.0 is the current release we are on. And 5.1 is expected in April, so it's not very far. 5.1 is actually very exciting because there are a lot of new features coming in, like device fingerprint-based policies, where now I can say, okay, this is a Roku device, and I'm going to automatically apply a policy. A lot of that functionality is coming in via device fingerprinting, and of course, we are also getting refreshed user interfaces for both admins and end user devices as well.
All right, and with that, I would like to thank you all for attending today's webinar. You will receive a recording of the webinar within the next couple of days. And if anyone does have any other questions, feel free to reach out, and we'll answer those for you. So thanks, everyone, and have a great rest of your day.
Thanks, everyone.